This video will walk you through the descriptive analysis tools that RegressIt provides. See the instruction handout for details of loading the files and starting up the program. This has already been done here, so the data worksheet is in view and the RegressIt ribbon appears at the top of the screen. There are 40 buttons on the ribbon, and they provide some analysis and navigation tools that you won't find in any other software. 40 buttons may sound like a lot, but you'll find good use for most of them in the course of 20 minutes of work, as you'll see in this demonstration. When doing regression analysis or evaluating work done by others, you'll often study and compare the table and chart output of many models, and RegressIt is designed to make that easy and systematic. There are also two alternatives to the ribbon interface, the vertical and horizontal floating toolbars. Clicking the Toolbar V button, or hitting Ctrl-G, launches the vertical toolbar, which has the same button arrangement turned sideways. This is usually a better option for use on small screens or touch screens because it maximizes vertical space for output, it has bigger buttons, and your hand doesn't block your view when using it on a touch screen. The horizontal floating toolbar, launched from the Toolbar H button, has the same button layout as the ribbon, and it also has larger buttons. The floating toolbars can be placed outside the Excel window, and that needs to be done on a Mac to keep them in view at all times. If you launch a floating toolbar on the Mac, and it later disappears and seemingly cannot be relaunched, it's probably active but hiding behind the window of Excel or another program. Here's what the vertical toolbar looks like when placed to the right of the Excel window. And here's what the horizontal toolbar looks like when placed below it. Before running any new analysis, let's try out a tool that provides an aerial view of the contents of the file. Click the History button on the RegressIt ribbon. This opens a window that lists all of the worksheets with some information about their contents, including dependent variable names and bottom-line statistics for regression models. The runtime of each analysis and the name of the computer on which it was run are also included. Very useful if your work is carried out on more than one computer at different points in time, or you are an instructor grading student work. This window provides not only an audit trail, but also a random access navigation tool. You can click on the line for any worksheet in the file, and then jump directly to it from here by clicking the Move to Sheet button. This box can be left open while you're working, but I will close it for now. Now let's go to the Data by hitting the Data button on the ribbon. The Data worksheet is always the first worksheet in the file. This dataset has 6 variables, one called Y that will serve as the dependent variable in the regression models, and 5 others called X1 through X5 that are candidates for independent variables. There is also a date index variable that will be used for plotting. There are 250 observations of them, except that the last 5 values of Y are missing for purposes of forecasting. The file contains 3 descriptive statistics analyses and 5 regression models previously fitted to the data. In this test, we will rerun them all. Next, let's go to the Stats1 worksheet by hitting the Right button on the RegressIt ribbon. This descriptive analysis includes all 6 variables and all the table and chart options, which consist of 3 tables and 48 charts in this case. Also, Y has been designated as the first variable, so that it will appear first in table and chart arrays, out of alphabetical order. Usually you will want to do this for your dependent variable if you're planning to fit regression models later. Rerun this analysis by going to the RegressIt ribbon and clicking the Descriptive Statistics button, which will open the dialog box for this procedure. The same variable selections and analysis options will be pre-selected by default, and the default name for the new analysis will be Stats4, the next number in the sequence of stats sheets. You can enter a different name if you want, but just hit Run to rerun exactly the same analysis. As the output is generated, you'll see progress messages in the lower left corner of the Excel window. They're a bit hard to read on a PC because of the dark green background. When the analysis is complete, the word Ready appears in the message bar. On this computer, the analysis runs in 5 seconds, but it could take 20 seconds or more on yours to produce all the charts. Initially, all you will see are the title rows above the table and chart groups. Hit the Show All button on the ribbon to open them all up. There's a lot of output. If you go to the Regress It ribbon and click the Zoom Out button a few times, you can see how much there is. Now click Zoom 100% to restore the original view. Then click the Last Stats button a few times. This will toggle you back and forth between this analysis and the original one. They should look identical. Normally you'll use this tool to jump back to the last stats sheet from a regression model sheet. Now let's take a closer look at the tables and charts on the Stats 4 sheet. Use the down key on the ribbon to move down the worksheet. You could use Excel's own worksheet navigation tools for this, but RegressIt's up and down buttons page up and down the worksheet by whole table and whole chart, so that the topmost one is always perfectly aligned with the top of the screen, and no fine adjustments are needed. Moving from top to bottom, you see the Descriptive Statistics table, Autocorrelation table, Series plots, Histogram plots, Correlation matrix, and Scatter plots. Each chart is a native Excel chart that is subject to editing if you've chosen the Editable Chart option at runtime, and they're formatted for presentation with variable names and key statistics in their titles. Now use the up arrow to move up to the correlation matrix from the bottom of the scatter plot matrix and hit the Zoom In button to enlarge it. Notice that it has Y in the first column to make it easy to focus on its correlations with the X variables. If you toggle the Colors button on the ribbon, color coding will be applied to the values, blue for positive and red for negative, with darker colors for larger magnitudes. The Fonts button works similarly to highlight the magnitudes of numbers by font darkness. The same color scheme applies to the autocorrelation table above. Notice that both X1 and X4 are highly correlated with Y, X1 a little more so, but they are even more highly correlated with each other, so perhaps there's some redundancy. Now click the left button a couple of times to move over to the Stats 2 sheet. Click the Descriptive Statistics button, followed by Run, to rerun the analysis. It differs from the first one in that it includes high-resolution fixed format charts rather than editable charts, and the series charts are formatted with vertical bars instead of points and lines, and the only scatter plots are those of Y versus the other 5 variables, a preview of simple linear regression models that might be fitted. Again, you can zoom out to see all the output, then zoom back to 100%, then toggle the Last Stats button to go back and forth to the original. Now move to the Stats 3 worksheet and rerun its analysis. This one consists only of a descriptive statistics table and a table of correlations and squared correlations versus the first variable. You can use this table to help identify the most important predictors of Y. Here, too, it is interesting to toggle the Colors and Fonts button on the ribbon to highlight the most significant correlations. As you know, the squared correlation between two variables is the value of R squared that you would get in a simple regression of one on the other. That's why it's called R squared. You can sort this table on squared correlations versus Y as follows. Click any cell in the table, and then click the Filter button on the Regress It ribbon. This turns on arrows that allow you to sort on any column. Click the arrow above the squared correlation column and choose the largest to smallest option. The variables with the smallest squared correlations with Y now appear at the bottom. If you launch a regression model from this sheet by clicking the Linear Regression button, as I'm doing here, the initial selections of dependent and independent variables will be pulled from it, with the first variable as the dependent variable. All of the other variables will be pre-selected as independent variables unless you have deselected them first. Let's cancel out and return to the Stats 3 sheet and see how this works. To deselect one or more variables, select a cell or a range of cells that spans their rows in the squared correlation table and hit the Remove button on the Regress It ribbon. This will cause their lines in the table to be grayed out. If you now launch the regression procedure from here, those variables will not be in the default selections. Here I am deselecting variable x2, whose squared correlation with y is virtually 0. If you click the linear regression button again, you can see that it is no longer pre-selected. Don't bother to run this model though, just hit cancel. By the way, in a multiple regression model, the fact that a given independent variable has only a tiny correlation with the dependent variable does not necessarily imply that it should be removed a priori. In some cases, it may turn out to contribute to the model's performance when used in combination with other variables. Or there may be logical reasons for including it, such as when it is one of a matched set of dummy variables that are used to model an exhaustive set of events or experimental treatments. Now go on to the second video, linear regression.